Assalamu alaikum wa rahmatullahi wa barakatuh. Thank you all for making it today. And today, our session here is the first space-themed session for the forum. I really look forward to this conversation that we're going to have on will space shape the next century? We are very biased towards that's the fact. And with that in mind, let me introduce our speakers. First, with Michal on my right. She is a space architect, founder of Ziso Innovation and Architecture Lab, and founder and CEO of the Sleep dual-use space tech startup. To her right, we have Diego Urbina, who is the Future Projects and Exploration Team Leader at Space Applications Services in Belgium, and the European Space Agency's crew member in the Mars 500 mission. To his right, we have Dr. Athena Coustenis, Chair of COSPAR, Planetary Protection Panel, as well as the Chair of the European Space Agency's Human Spaceflight and Exploration Science Advisory Committee. And to her right, finally, we have Mark Beer, who is the Minister of Justice for Asgardia, the co-founder of 7 Pillars Law, Chairman of the Metis Institute, and the co-founder of the University of Oxford's Deep Tech Dispute Resolution Lab. Please welcome our speakers for today. So to get the juices flowing, and since we're in the Dubai Future Forum, the question for the panelists is, in 1 minute, and we'll start with Michal, what is your forecast for the next 50 years in space exploration? No pressure.
No pressure. Can you hear me? Yes. Hi, everyone. It's great to be here. Well, I think that we are now living in, we are living in the new space era. That means that more people are starting to become aware of what is happening in space. And not only that, in the next 50 years, we are going to see more and more people going to space. And even us are going to start going from point to point on Earth using spaceships instead of airplanes. There are airports being built around the world. 44, I think, is the current number. So a lot of us are going to experience space. And there's a unique thing that is happening when you experience space. When you see Earth in one vision, you don't see borders. You see one very delicate kind of blue marble, and there's something that's called the overview effect. It's a shift in consciousness that makes you think about everything very, very differently. So that would be very, very exciting.
All right, then that will create, I'm sure, a ripple effect on everything. Diego?
All right, so I think that we're set for a very exciting 5 decades that are coming. Within this decade, we're going back to the moon. We're going to start to learn how to use the resources of the moon, doing many experiments and testing different things that will help us later living on the moon. That's going to be perhaps the next decade. We're going to be living for the first time for longer periods on a planetary body. And this will teach us a great deal about how to live even further into the solar system. Within the next 2-3 decades, we're going to establish an economy in space. So we're going to be doing in space all the economic activities that we do on Earth, but there. And hopefully, soon enough, we're going to be living on Mars. Yeah, I hope that this will be within my lifetime. So it's quite exciting what's going on.
Thank you, Diego. Dr. Athena?
Yes, I don't know if you can hear me. I hear a lot of noise in this room myself. But I think to this tough question, there is one certainty for the future. And that certainty is that everybody in this room, including those people back there, are curious. Everybody has curiosity. Curiosity leads to exploration. Exploration leads to knowledge. So I think that one thing is for sure, that in the coming decades, we will increase our knowledge. And because we're talking about space, I will tell you that there is one fundamental question that we're going to be able to answer in the next 50 years, I hope. And that is there life elsewhere in the solar system? Because that is one fundamental question that us scientists, space scientists, need to answer. Because if life has emerged in different environments, in different places, then it mind blows our whole concept of how life came to be. So this is my prediction for the next decade.
That's the trillion-dollar question. Is there life in the solar system? Mark?
Thank you very much, Saeed, and it's so wonderful to be here in the city of the future, in a country that's committed to the future. We're coming off the back of connecting minds and creating the future, now looking at how we're going to design the future and how we're going to execute on it, and it's wonderful to be around such brilliant people. Now, they do say it's dangerous to make predictions, especially about the future. But I'm going to try and do it, and this is what I think the answer is. Within 50 years, we will be living on the moon. Within 100 years, we will be living on Mars. Elon Musk thinks there's going to be 1 million of us living on Mars by the end of the century. But what will be the accelerator? What will drive this transition to be living on the moon and on Mars? Unfortunately, I predict it will be an existential event. It will not happen organically. It will be war, it will be disease, or it will be climate and famine. But those three existential threats, I think, will accelerate us towards looking to live on other planets within 50 years.
All right, thank you, Mark. And I'm glad you mentioned these points. You're the only one in the panel that has looked extensively, at least from a legal perspective. And my question is sort of what do you foresee, or how do you think humanity will be able to go past some legal and regulatory hurdles in space, since it's an uncharted territory to some extent?
Well, we do have some of the world's leading space lawyers in the room, so I express this with a degree of caution. But there are two types of laws that apply to space. Treaty-based laws, the last significant one was in 1967, and then sort of general accords. And I think we'll all agree that the world is not in a place where we're likely to get universal national consensus for treaties. So I think we're going to move towards more consensus-based decision-making. And that consensus can't just be driven by the government. It's got to be driven by the synthesis of the government and private sector. Because Morgan Stanley says space will be worth $1 trillion by 2040 to the business community. Tourism alone estimated to be worth $3 billion by 2030. So the private sector and the public sector are going to have to come together to start making rules. And those rules are not going to be defined by borders and barriers and tariffs, which is how we've designed the nation since 1648, the Treaty of Westphalia. Our first in 300 years of humankind, our first nation state was created within the last 400. It's not going to be based on control. It's going to be based on consensus. It's not going to be based on control. It's going to be based on consensus. And we've got to move in these environments away from what I call the ecosystems. It's my country, it's my sovereignty, it's my laws, it's my regulation, it's my citizen. An ecosystem, we've got to move to an ecosystem where we're all in it together, because we will not survive on Mars and we will not survive on the moon unless we're all in it together, private and public, and humans all working together for the greater good. So I think what we're going to see is laws and regulations as we know them will move from control-based to consensus-based, and I think we've got to move away from me into us.
How practical is that? We don't see that happening here on Earth, let alone off Earth.
Yeah, and look, that's going to be the question, because it won't happen. We won't be able to achieve our ambitions in space until we do start to have consensus. Because, if you think in this room that we will get the United Nations together for a treaty like they did in 1967, given the state of the world today, raise your hands if you think that will happen. Because if it isn't going to happen, then it's got to be done by consensus. And space is no longer the final frontier, it's the next frontier. So if we're going to get there, if we're going to generate $1 trillion of economic value, then we've got to do it by consensus.
Dr. Athena, I think you had something to add to that.
I think there is something happening these days on Earth. So you mentioned before that I'm currently chairing the COSPAR Planetary Protection panel. And planetary protection is all about protecting outside space and protecting the Earth. Okay, so we have 12 space agencies in that panel, and we have an equal number of scientists, just to make sure that any discussion there has a balance and has a profit. And the idea is to bring regulations on how do we go about this space for all, space for everybody, but in a safe and sustainable way. And we have the private sector, and we have the space agencies' representatives. And what is the idea? The idea is exactly what you were saying before, Mark, that we are afraid, we're scared about what we can do to space and what we can do to our own planet. And fear is a very good motivation for doing things and for applying regulations. The idea is if you go out to Mars and you said we'll live there, okay? But what if we destroy the environment there? What if we destroy the evidence of what Mars can teach us about the Earth? What Mars can teach us about where we came from, about life emergence, and about climate change. That's not good, right? So we have to do it in a very safe and sustainable way. And what if we go to Mars and we bring back a sample, and that sample has extraterrestrial life? We need protocols, we need protection, we need to have the right measures. So this is what we take on board as scientists and agency representatives, and the private sector is very much willing not to be branded with "you destroyed the Earth." And so they come to our table and we have this kind of discussions. It's one step, it's one tiny little thing, but every tiny little thing leads to knowledge, as I was saying before, leads to us coming together behind safe and sustainable exploration of space.
Thank you for that. Diego, I wanted to ask you, since you've been on a simulated mission, you have been as close to any of us to a simulated situation in terms of long duration missions, right? In your opinion, how close are we to becoming that multi-planetary species or off-world species?
Yeah, so I think it still will take some work. There's many things that we still need to figure out: how to survive with radiation in space, how to deliver the astronauts safe to that planet, how to make sure that we can supply spare parts, or in fact manufacture them on site to maintain the settlement. So there are many things that we have to figure out, but I believe that we're taking the right steps. We're lowering the costs of access to space, which is quite important, through reusable rockets. We're going to explore the moon, which is quite important for us to learn how it is to live on a different planetary body, but with a little bit less risk than living on Mars yet. This will teach us a lot about living on Mars. And we're also creating this space economy that would make it more feasible to have these future space settlements, if nothing else, because we're going to reduce the cost of being able to do so. So I think we're on the right track. It will take a few decades to be able to get there, but we're on the right track.
Just to touch on that, is there a way, in your opinion, that we, may responsibly expedite or accelerate that process?
I think to accelerate that process, we can invest more. Governments can invest more. We can also private ventures can take more risks, invest more, and that would certainly accelerate our development. And ultimately, it will depend a lot in the next decade or next couple of decades on the level of success that these private ventures can have in space. and that could make it even much quicker than what I'm saying. So I think that there's many variables there.
Thank you for that.
I can add to that.
Go ahead.
I think it's not only an option to accelerate it, I think it's necessary. Looking at Earth, we are living in an environment, maybe not so in Dubai because it's very advanced, but all over the world, we're living in environments that were designed, and infrastructures that were designed hundreds of years ago as a different social structure, different technology, different times, and it's very hard for us to keep up with the pace of change. In space, it takes even longer to design the very, very complex infrastructure to actually live in space. And we have to start accelerating that thinking process because we are talking about the people that will live in space will not be us. It will be our children, our grandchildren, and we have to be able to design today environments for the future for them. And a lot of people it's a very interesting kind of balance to thinking how we are designing for ourselves if we would go to space, as opposed to how we should actually design, which is for diverse people that are much younger today that will eventually be the ones who are living in space. So I started to work in the field and I talked to people and they said, well, you're an architect, you're too early for the game. And I was like, nope, you are too late. I think we have to do this work and type of thinking now and really think about how people can thrive in space as opposed to just surviving. So it's something that is necessary to accelerate what we're doing.
And I wanted to ask you, Diego mentioned that there are a few things we need to sort out before we can not only, live in space and be able to function, but again, to thrive. And we've heard that design or human-centered design as part of foresight, as part of policy making, and not so much in space. And you're one of the few people I've met that actually focuses on that. So if you want to touch upon it.
Yeah, definitely. So as I mentioned, we are living in the new space era. That means that the power is coming in the hands of commercial entities, private entities, as opposed to governments. That means, on the one hand, that we can do things faster. On the other hand, it means that there are specific people who are making decisions that are maybe yes or no relevant to everyone. And when we're talking about human-centered design, we should think about how different types of people, let's say people with disabilities, how will they go to space? How will they experience space? Maybe their disabilities on Earth will become superpowers in space. We have a lot of ways to think about it in a new way because we are no longer looking at the superhuman astronauts that are there enduring very, very harsh environments. They can work under extreme pressures and they don't complain. We're looking towards a completely different future, and this is a time where everything is shifting. So today I am one of the few space architects who focused on inclusive-based, human-centered design. I was privileged to speak to engineers and scientists at NASA about this, and I hope more people will join me because I think this is something that we have to kind of put our finger on and hurry to do and impact and change the way things are going, because we don't want to end up how we're ending up here on Earth. That is really hard to change things that we already placed. So.
Thank you for
If
that.
I may add to that, sorry.
Absolutely.
The research that people like Michal are doing is quite important towards having this multi-planet civilization. In the Mars 500 mission, I realized how important it is to have a nice place to live that cannot only be this tin can in which you may have, if you live in just a tin can for the rest of your life, let's face it, you may have a pretty miserable life. So it is important that you have something to look forward, something positive for the future. If you ask me before the Mars 500 mission if I would go on a one-way round trip to Mars with 5 people living in a tin can forever, I would have said yes. But after the mission, I realized how important it is to have something, how connected you are to humankind, and how better it might be to live rather than with just 5 people, with maybe hundreds, thousands of people in a nice, habitable place that gives you some will to live. And that's what we ultimately want from expanding humankind into the solar system. So it's quite important.
Yeah. I'm very much inspired by what you just said, because habitability is my specialty, I just wanted to, and we are discussing future, right, here. I just wanted to take us back to some basic things. And this is, what do we need? I mean, well-being is one thing, but what do we need to survive as a terrestrial living form? What do you need today? What do you need to live?
So you need water, food, energy security.
Okay, water, energy, well, you need the heat, right? I mean, if you live in a cold country, then you suffer. What else do you need? Nobody here needs to eat. You need nutrients, okay? You need energy, water, nutrients, and the other thing you need is a stable environment, because if you're not in a stable environment, you don't have enough time for metabolism. Okay, good, because you are knowledgeable people. Usually when I ask that question, people say oxygen. You don't need oxygen. Life did not emerge in an oxygen-laden environment. So these are the things that we look for in habitable environments in the solar system. This is what space missions are about. Space missions is about finding water in other places, organics, that's the chemistry, that's the nutrients, energy sources, and a stable environment. This is our exploration. If we can't find those things out there, then one of the messages is you have to protect what we have here on Earth. The second message is, what can you bring out there? So we're talking about the future, right? Okay, maybe I can bring water. Maybe I can find it. Maybe I can dig it out. Maybe I can get some organics. But the only other place in the solar system where you have organic chemistry is not on Mars. It's not on the moon. You don't even have an atmosphere there. My favorite object is Titan. Okay, Titan is a long way from here. It's a satellite around Saturn, but it has nitrogen atmosphere. And by the way, what are you breathing all right now? What are you breathing? You're breathing nitrogen. 78% of what you're breathing right now is N2. So Titan has N2. It has water ice on the surface, and it has an organic chemistry. So I'm selling places over there in Titan if anybody wants them. But frankly, it's far away, okay? It takes us 8 years to get there. So nothing is easy. So we start by protecting our Earth here and living species here. And then we look at what we can do in the future. And in the future, as Mark was saying, maybe we'll go live somewhere, perhaps on Mars, perhaps on Titan. But it's not going to be easy. And that's the message I just want people to understand. Nothing is easy out there. Space missions are fine, I designed them, but that doesn't take you to where a living organism can survive.
And I wanted to ask you on that, you focus a lot on in-situ resource utilization, right? When you're talking about food, water, or even energy. It sounds much easier than what it is, trying to get your resources from an off-world location.
From where? I'm
sorry. In-situ resource utilization.
Yeah,
so
in situ.
If you or even Diego can touch on this in terms of what are you seeing in terms of that development, and where do we seem to be headed as sector?
Yeah, the private sector is extremely interested in mining, for instance, the moon or mining Mars. That doesn't get you very far, let me tell you. The biosphere experiment on Earth, they tried it so many times. It failed every time. There is no way that you can get everything that you need for the human being today with the means that we have. I'm hoping in the future, but it's not the in-situ resources on the moon. There's so little water, if there is any water, in the permanently shadowed regions. There's so little metal that you can extract. The hydrogen for you to get propulsion systems is very short in limited, quantities. So what you really need is to be able to transport from here, from the Earth, in some locations where you want to build bases. We need bases to go from the Earth to the moon, from the moon to Mars, from Mars to Titan. It's a stepwise process that is going to take quite some time. So in situ resources, yes, for a short time and for limited things, but not for a sustainable future.
Yes, indeed, as Athena said, that there's very little chance that we can get absolutely everything we need from the moon or from other planetary bodies. But there is quite a good deal of things that we can get from there. If we look at the moon, about 40% of what we're looking at is oxygen that is in the lunar regolith that we can extract. We can make a propellant out of that. It's the largest part of a rocket is full of oxygen. We don't need to take it if we get it from the moon. We can make oxygen for astronauts to breathe. We can extract metals from the oxides on the lunar surface to make spare parts for the lunar missions. We can build infrastructure on the moon, and the benefit of in situ resource utilization is that it can save us a lot of money that we would otherwise not even be able to spend when we work on these missions. So that's in the short term that we're going to do that. We are going to first to demonstrate that it's possible. We'll be working with the European Space Agency to demonstrate the first extraction of the first 100 grams of oxygen from the lunar surface by the mid-2020s. We're also considering the sun as a resource because we can provide energy. We're designing a charging station for the moon where people can come and charge their robots and charge all their systems, and we can sell that as a service. So that helps enabling that short-term space economy. And in the longer term, rather long, we can think of moving resources between planets. We can even bring resources to Earth, things that are very valuable and that are widely available in space, bring them back to Earth, and bring in even propellant to the Earth orbit to power satellites that are flying to different orbits. So I think that the space resources pave the way to be able to do affordable exploration and living on other planets, which is quite nice.
Oh, thank you for that.
I can add on that, if I may. Sure. A lot of times when we're thinking about space, we're kind of trying to solve a 1,000-piece puzzle in our head. And sometimes we just have to start, and things will happen, and things that we don't necessarily expect can happen. A lot of times when we talk about how will our life on the moon or on Mars will look, there's always one or two answers, or this is the best way, and of course there is no one right answer, like there is no one way of living on Earth. Like Diego mentioned, there are already startup companies creating amazing innovation about extracting oxygen from the moon regolith. There's a company, Israeli company called Helios. They contacted me. They said, listen, during our process, we get oxygen, but we also get liquid metals that we can put into forms and then afterwards use for architecture. What would look, the future space architecture on the moon, what would it look like if it was built from metals and steel? Now, when you think about moon or lunar architecture, you don't necessarily think of those resources, but that specific technology can give us an abundance of a specific material. So a lot of times things will happen that we don't really expect or understand or prepare for, but we kind of have to be agile enough to shift the way we work and the way we do things as things go. And the other thing that I wanted to say is that one of the former NASA administrator, Mr. Charles Bolden, who was also an astronaut, he always says that the first reason that we explore space is for the benefit of Earth. So a lot of times, doing things differently in space can allow us to really think about how to innovate and even disrupt things that we are so used to doing the same way on Earth.
Yeah. So off Earth, for Earth, basically.
Exactly.
That's the NASA slogan. Mark, since we were touching on the moon, China a few months ago announced that they're really interested in getting helium-3 to be able to build miniaturized nuclear reactors here on Earth. As someone that's looking at what Michal was saying, new frontiers that we have yet to understand in space, what are your sort of insights on how do we go ahead and addressing these aspects?
As I say, I think a lot of what we've heard is not about complexity, because much is possible today. What we're hearing is the challenge is cost. It's the cost of moving organic matter to another planet. It's the cost of transporting the infrastructure that we can build to another planet or using infrastructure that exists. It's about cost. If we look back in history, at the point at which the maximum investment has been made financially in changing the world, it tends to come out of existential threat. The Second World War gave us the first electric computer. Why? Because in Bletchley Park, they needed to crack the Enigma code. The Second World War gave us the first jet engine. Why? Because air superiority was going to be the way to win the war. And the Second World War gave us $2 billion, that's in 1945, $2 billion, 125,000 person nuclear program to create the nuclear bomb. Out of existential crisis comes investment to transition us into a new way of doing it. And that's why I think for space, for what we're talking about, it will not come out of an organic discussion. It will come out of a need, be it disease, be it war, be it famine induced by climate. But that's what will trigger it. Sadly, it won't come out of scientific inquisitiveness, right? And then we start thinking about investment in space. Now, way back when Henry Ford wanted to build a factory, he didn't have the money. So he went to friends and family in the bank and he said, lend me the money to build a car factory. I've got a model, I've got a thought about how we can mechanize the design of a car. And he went to his lawyer and he said, would you lend me $5,000? And the lawyer went to his bank manager and said, this guy Henry Ford, he knows a bit about cars, he wants to build a factory, he's asked me if I can borrow $5,000, which was a lot of money in those days. To which the bank manager said, the horse is here to stay, but the automobile is only a novelty. Do not invest the money. The lawyer gave Henry Ford $5,000. It became worth $12.5 million. So the reality that we have today, space is hard, space is difficult, space is expensive, coming out of some existential event which causes the world to invest in looking abroad, and then comes to individuals like us in the private sector and said, do you want to come in as well? I think that will be the accelerator that moves us towards doing the unimaginable, the modern day moon landing, which is starting to build communities on the moon within 50 years and on Mars within 100 years. I think those will be the drivers.
Thank you for that. And it leads me to a question for the rest of the panelists, since we have enough time just for everyone to contribute. We have a room full of futurists, people in government, private sector, academia. How can other industries, in your opinion, with what was mentioned today, learn from the space sector in trying to anticipate the future opportunities as well as challenges, in your opinion? So I think we'll start with Athena.
Yeah, so in 2010, I decided to build a space mission from scratch with this crazy idea that I was going to fly a balloon on Titan. Because like I said before, Titan, I'm a bit biased, okay, but it has a very thick atmosphere and you can fly anything in it. You can fly an airplane, you can fly a balloon. And nobody, absolutely nobody, at the observatory where I work, and including the European Space Agency, thought that that was possible or feasible. So I went to see Airbus. And I said, well, I have this crazy idea about a balloon. And they were so happy. And they lent me, I don't know how many people, not money, but people who helped me, design this balloon that was going to fly in there. And by the way, wouldn't you want to land something there? How about landing something on a sea? Titan has seas of hydrocarbon. And they helped me design the lander that was going to go there and everything. And by that time, Thales Alenia Space had heard about it. And they called me on the phone and said, oh, we would like to help. Would you like us to come on board? And these are big industries, but I also had smaller industries, OHB in Germany, and people from Italy and everywhere. Saying, in Luxembourg, saying, yeah, we'd like to come on board and help with that. And it's exactly what you were saying. It wasn't the banks, but it was the industry who thought that the idea was exciting. And it went on every magazine around the world. You have this balloon flying in Titan's atmosphere with a lander landing on an extraterrestrial sea. And it's just the imagination of people. And people have this kind of imagination and can see further that will help you. Whether it's the private sector, whether it's the industry, whether it's the scientists or somebody else, the miracle happens when everybody comes together. The miracle happens when people come together with one of those dreams, and then my God, it's fireworks, right?
Absolutely.
And so we need everybody on board, and I need my students, and my students are the younger generation who come to me and say, oh, I have this crazy idea. And I say, okay, what is it? I want to build a space city that is going like this and that around the Earth, I say, okay, let's sit down and think about it. So I think, Mark, you're right, but the curiosity, whether it comes from scientists, whether it comes from, banks, or whether it comes from the industry, is what is going to drive us.
To build on that, I can
Go ahead.
maybe go next. Not only we need everybody, we need a community of people. Exploring space is not something that one sector could do alone, not something even that one government or one country could do alone. It's something that is a joint effort, and it's also multidisciplinary. When we are designing a spacecraft, it's not just aerospace engineers, it's them as well as space doctors and psychologists and architects and designers. And a lot of people have to contribute to doing one thing. And I think that's something that we can implement here on Earth, even in our, for example, academic institution. Maybe there is a room for a change not to have different faculties. Maybe projects or things should be learned together, because we are thinking in space, and we should start thinking on Earth also in a way that is more interdisciplinary. How different views, different expertise can contribute to a joint goal. So I think that's something that we, different sectors can take from space and implement.
Oh, thank you for that. Diego?
Yes, I think that we need each other, definitely. So we, as private industry, cannot necessarily just go now and build everything in space. I think the idea in the near term is that we could have space agencies and governments as anchor customers of services, and agencies like NASA have already realized this and are being very smart about this, and are, for example, for their lunar missions, are not necessarily building absolutely everything they need, but are leaving some room for private companies, for smart entrepreneurs to come and propose a business model and deliver things as a service. And I think that is key, because at the beginning it will be a service provided to governments, but on the long run it will be services provided by privates also to privates, and this will lead to many other wonderful things in space. So I think that we need definitely each other. Yeah.
I think, so to wrap it all together, I remember hearing this from members of the Emirates Mars mission, the HOPE probe team. They had the mantra of saying that if we do our jobs perfectly, as people in the space sector, it will not be us or our children who will be benefiting from the work that we're doing here, but it will be our grandchildren. Because of, as Michal mentioned, the interdisciplinary the interdisciplinary notion of space and the way it works spills over to everything. And on that note, I would like to thank you, our panelists. Please join me in thanking them. And we hope that you enjoy the rest of the forum, and we thank you again for making it. Have a wonderful day. Assalamu alaikum.